All right, stats. So now we're going to find or do a significance test about a difference between two proportions. So again, here are your hypotheses and your conditions when you're doing a significance test with a P1 minus P2. So your null hypothesis, we are going to assume that there is no difference between the two proportions. So if you were to subtract them, if there's no difference, then that would be at difference of 0. Or a little simpler stated, we'll just say that the two proportions are equal. P1 equals P2. For your alternative hypothesis, so if you're going to be a one-sided, you could have a less than or greater than symbol, or if you're a two-sided, then you're not equal to. Okay, and the conditions are still going to be the random and large counts condition, just like the confidence intervals. Again, remember, because there's two proportions, you have to do things twice. Now, there is a sort of a major difference when doing the standardized test statistic. So when you look at this, it is a z. Anytime you work with the proportions, it's a z. But notice up here, right? You're going to use the sample proportions. You're going to subtract them, right? That's simple. You don't need this minus 0. That's just what the form really says. Again, the null value or the null assumption is that there's a difference of 0. So you take the sample difference minus the null difference, but it's just 0. And now this bottom, notice here, you see this p hat c, right? We don't use p hat 1 or p hat 1, p hat 2. We still use the sample sizes for the first group and the second group, but instead we're going to find this p hat c, which is called the combined sample proportion, or in statistics it's called pooling. Okay, and here's the idea. If we assume that there is no difference between the two proportions, then why not lump everything together? Lump the combined number of successes from both samples over the total of the two samples, and that'll give you even a better proportion value. Okay, so again, that's what this is. So x1, x2, these are the number of successes, and then n1 and 2 are the sample sizes. Okay, and we'll talk about what that means in our problem. So again, this is the major difference between what we've done in the past and what we're going to do today. Again, just one extra hurdle to overcome. You can do it, promise. Okie doke. And then when you find your p-value, again, you're going to use technology. That's the stats applet. Again, we're going to have our z value. You're going to have to find the p-value that goes along. And again, the inference method is called a two-sample z-test for a difference in proportions. So it's a two-sample z-test for p1 minus p2, right? And that's what we're going to be doing in our plan. Okay, so I think the problem comes up next. Let's get right to it. Okay, here we go. So it says, do financial incentives help people quit smoking? In an effort to reduce healthcare costs, General Motors sponsored a study to help employees stop smoking. So it is true that companies get incentives if you have less employees that use tobacco. I know my dad, he works for Nestle Gerber, and he has to take a survey as well. In the study, half of the subjects, 439, were randomly assigned to receive $750 if they agreed to quit smoking for a year, while the other half, 439, were simply encouraged to use traditional methods to stop smoking. So again, not always will the sample size be the same. This time they were. None of the 878 volunteers knew there was a financial incentive when they first signed up. At the end of 1 year, 15% of those with the financial rewards group had quit, while only 5% in the traditional group had quit. The results of this study give convincing evidence at the 0.01 alpha equals 0.01 significance level that a financial incentive helps people stop smoking. Let P1 minus P2 be the difference. Financial incentive minus traditional methods. Okay, so I have done the state and part of the plan for you. So state, we want to perform a test at the alpha equals 0.01 significance level of, and again, we are null hypothesis that the two proportions are identical, meaning the financial incentive would have no impact, versus the alternative, we think that more people in the financial incentive group will quit smoking than the traditional. So P1 is greater than P2, where P1 is the true proportion of all GM employees who stop smoking given the financial incentive, and P2 is the true proportion of all GM employees who stop smoking using traditional methods. So plan, we're going to do a two-sample z-test for P1 minus P2. All right, let's get after it. Okay, so within our plan, we have to do the random condition. So our right here, half the subjects were randomly assigned to receive, other half other half simply encouraged to use traditionals. So half of the subjects, 439, were randomly assigned. And there we go. That's good. And the other half then got the second group. So again, that's all we need. So half of the subjects, 439, were randomly assigned. And then we need to do the large counts. So your first sample size for the financial group is 439. And of those, 15% quit smoking. So 439 is your sample size, and your p hat 1. Now, this was nice. They gave us the percentage. It's 0.15. Remember, sometimes you have to find that value. I'll just color code this. 4 and 2, again, the sample size was still 439. But now your p hat 2, only 5% traditionally quit smoking. So that's 0.05. Okay, so to test your conditions, again, now I'm going to go back to blue. So n times 439, sorry. N times p hat 1 and 1 times p hat 1, 439 times 0.15 equals, when I just do that, 439 times 0.15, I get 65.85. That's greater than or equal to 10. And then I do 439 times 1 minus 0.15. And that is 439 times 373.17. Or 0.15, I don't know. That's also greater than or equal to 10. Do the same thing for N2. 439 times 0.05. So 5% of 439 is 21.95. That's greater than or equal to 10. And then do 439 times 1 minus 0.05. And that was 417.05. That's also greater than or equal to 10. So it passes the large counts condition. We can go ahead with the problem. So now let's go with the do part. Okay, so when we do this, remember the formula involves this p hat c. We have to find the combined sample proportion value. So p hat c is going to equal the number of successes. Now, this situation did not give us how many quit. It gave us the percent. So we need to take the 439 from the financial group and multiply it by the percentage that quit, 0.15. Add that to the 439 from the traditional methods group and multiply it by the 5% that decided to quit. This will give us the number of successes for each group. That's it goes on top. Most of the time they'll have the numbers, right? So if it said 439, 439 were put in that group and say 70 quit, then 70 would go on top, not this. All right, so be aware that this is just to get your number of successes. And that's going to go over the combined sample sizes of 439 plus 439. Okay, so let me do all that at once in Desmos graphing calculator. I'm going to take a picture because I don't want to forget what it looks like. Okay, so we'll come here, Desmos graphing calculator. So fraction, I'm doing 439 times 0.15 plus 439 times 0.05. Sorry, I don't know what I'm doing. Sorry. Over 439 plus 439. Wow, nice. I get a nice even number of 0.1. We're very lucky. If it's a decimal, round to 2 or 3 places. It seems like 3 is the safe bet. Some of you guys are only rounded to 2. Just, use common sense when you see the numbers. All right, so that's 0.1. So that is our combined sample proportion, 0.01. So in our do, our p hat combined is 0.1. Man. Okay, so now we have to do our Z standardized test statistic. So we're going to take our p hat 1 minus p hat 2, so 0.15 minus 0.05. Again, it's incentive minus traditional. Over, now here's this big thing. It's your p hat c times 1 minus P at C all over the first sample size plus P at C times 1 minus P at C all over the second sample size. Again, not always identical, and that's inside a big square root. This I need to multiply to 3 decimals. So let's go do that in graphing calculator. So the top fraction was 0.15 minus 0.05. The bottom is a big square root. The first fraction is 0.1 times 1 times 1 minus 0.1 all over 439. The second fraction is identical. 0.1 times 1 minus 0.1, 1 minus 0.1 all over 439. And there we go. That's our z value for our problem. So our z is going to be 4.93, and the 5 makes the 8 become a 9. 4.939. So now we're going to go on to our probability stats applet to find our p value. Remember that our alternative hypothesis was a p1 greater than p2. So we're looking for the right tail only, greater than, to the right of 4.939. So let's go do that now. Now remember, typically on this stats applet, you're looking for z's of negative 3.5 to 3.5. So a z of 4.939, that's quite large. All right, so maybe you are thinking, we are finding a probability, so we're finding an area. 0 and 1 are our normal standard, our standard normal distribution, mean and standard deviation. Find the values to the right of 4.939. That gives us an area of 0. So your probability of this happening by chance is 0. So your p-value is 0. Okay, so now let's go back to our notes and let's conclude. So what in the world does that mean? Well, we're still going to use the same conclusion we did before. So to conclude, so p-value of 0 is less than 0.01. So we reject the null. Same idea. If we reject them all, that means we found convincing evidence. There is convincing evidence that the true, and now I'm going to interpret what the alternative hypothesis said. Remember, the alternative hypothesis said that P1 was greater than P2. So I'm going to interpret that. There is convincing evidence that the true proportion, and this would all come from the state, that the true proportion of all GM employees who stopped smoking, given a financial incentive, is greater than. And that's because that's what my inequality says, is greater than. And then what does P2 represent? Is greater than, not greater that, greater than the true proportion of all GM employees. Sorry, I'm getting sloppy because it's long, right? This is the one thing I think that using a computer helps. Typing is faster. Then the true proportion of all GM employees who stop smoking using traditional methods. There you go. So conclude your p-value of 0 is less than 0.01, so we reject the null. There is convincing evidence that the true proportion of all GM employees who stop smoking, given a financial incentive, is greater than the true proportion of all GM employees who stop smoking using traditional methods. And there we go. Okay, so according to this sample and this this experiment or significance test, the financial incentive did actually help. All right, so great. So again, there should be one problem for homework covering significance test and one problem covering a confidence interval. All right, good luck.